Hello. Today we are going to discuss one of the basic electrical element, that is resistor. So we have three basic elements, that is in passive case. One is a resistor, second one is inductor, third one is a capacitor. So now we are going to discuss the resistor or a resistance. In any material or conductor, when current flows, it opposes, the material or conductor opposes the flow of current. So that property of the material is called the resistance. So opposition to the movement of the electric charge movement is nothing but a flow of electric charge. So that is what the current. So the opposition to the movement of the electric charge in a material or a wire or a conductor. So this opposition influences the magnitude of the current when voltage source is connected. So the voltage source is the driving force for the charge, and whenever the charge moves in that material, the material will oppose that movement. So that property of that material is known as the resistance. So this is the idea of the inherent tendency to oppose the electric current. So generally, we are going to define the resistance with the help of a simple law called the Ohm's law. So let us consider the Ohm's law. So generally, Ohm is the unit. That is the reason why we are taking Ohm. So Ohm is the unit for the resistance. What is Ohm's law? So Ohm's law states that the current through a conductor is proportional to voltage applied across it, and the condition is at constant temperature. So the statement of the Ohm's law is at constant temperature, the current through a conductor or a material is proportional to the voltage applied across it. So for example, if you consider an element, a conductor with two terminals, the current through the, let me define. So the current through the element or the material, let me show. So the current through the material is proportional to the voltage applied across the two terminals. These are the two terminals, plus and minus, of the conductor. So therefore, the V is proportional to I is the relation which relates the Ohm's law. So the voltage applied across the element is proportional to the current through the element. When we convert this proportionality into equality, so then we are going to get V is equal to IR. So where R is called the proportionality constant, and this R depends on the nature of the material, right? So therefore, the R you can write as the ratio of V by I. So the voltage applied to the material and the current flow through the material. So that is the ratio of V by I is known as the resistance, and which is the property of this material which opposes the flow of current. So generally, if the voltage is constant, then your current will influenced by the resistance. So it means the opposition of the material influence the magnitude of the current. So this is what the simple Ohm's law, which relates voltage and current with the help of the resistance. And here the two things are very important. One is the constant temperature, another one is the properties of the material. It means one is a geometry and another one is nature of material. So let us discuss these two things. The first one, why at constant temperature? Because as we discussed in previous slide, so the Ohm's law statement is valid for at constant temperature. So that is the one thing we have to see, why at constant temperature and what are the parameters influence the resistance. Let us discuss why at constant temperature. So generally, the resistance of the material is nothing but the resistance of the material at the zero temperature, 0 degrees centigrade, plus R naught into alpha into this T minus T naught is the change in temperature. So whenever this change is zero, then R is equal to R naught. Otherwise, the R is the function of temperature. So that is the meaning of R of T. Very simple reason for this equation. Whenever we are taking a conducting material, so when we take conducting material, when we heat it, so definitely it will expand. So it will expand means whenever it expands, its geometry will change, means diameter will change and length of the material will change. So whenever the length of the material will change or the diameter will change, means the parameter of the material will change, so which influences the resistance. Therefore, definitely we can write the resistance as a function of temperature. So therefore, the R is expressed as a function of T, where T, capital T, is the temperature, which is expressed as R naught into 1 plus alpha of T minus T naught. See, actually, if this T equal to T naught, then this T minus T naught becomes 0. So therefore, R of T is equal to a constant value of R naught. So this is the meaning of at constant temperature. When we consider a variable temperature, definitely T is not equal to T naught. So when T is not equal to T naught, this term will added to the 1 and total value of resistance will increase or decrease based on the change in temperature as well as the alpha. So that is the coefficient of temperature, right? So this is the one thing we have to keep it in mind when we discuss the concept of resistance, the why we need to take that constant temperature. So when the temperature is constant, if you vary the voltage, then current is proportionally vary, and if you draw the characteristics between the V and I, then those characteristics are linear in nature. It is passing through the origin, actually. It is passing through the origin. And the slope of this line is constant, which is R. Actually, slope of this line is R. So if you want to take the slope, you have to take the y-axis is V and x-axis is I, so that V by I or dV by di is known as the resistance. Is known as the resistance, right? So this is the one concept at constant temperature. If the temperature is not constant, let me take a filament lamp, where if you increase the current, if you increase the voltage, then current will increase, automatically bulb will glow, and that will be dissipated in terms of heat, and that will increase the temperature, the surrounding temperature of the bulb. So therefore the temperature will increase and definitely the resistance will change. So whenever the resistance will change, V is equal to IR, I is variable and R is variable. So definitely the characteristics are not linear and they are non-linear in nature. So therefore it is not straight line, it is deviating from the straight line. So that's what we will see in the filament lamp, right? So this is another characteristics where the temperature is variable. So in the first case, the temperature is constant. In the second case, the temperature is variable, right? So this is the case where the temperature is constant, and this is the case where the temperature is variable. Let me take the same concept again. So for example, I'm taking a material whose resistivity is very low, means resistivity is very low means the slope is, no, the resistivity is very low means the current is very high. Because the denominator is high, then only the resistance value will be low. So that is the relation. Actually, R is equal to V by I. If you consider the slope dV by di, R is equal to dV by dA. So if R is very low, means di is very large. So now if you draw the characteristics, that is very close to y-axis. So this is how we will get a characteristics for a material whose resistance is very low. If you consider the material whose resistance is high, then automatically, which is nearer to the x-axis, where current is slowly increasing with the increase of voltage. So here the slope is close to 0, here the slope is close to 90 degrees, right? So that's how we can classify the materials in graphical manner. So this is the one topic where we can understand the resistance with respect to the temperature. Now the second point is what are the parameters influence the resistance. So generally at constant temperature, V is proportional to I and V is equal to IR, where if you are not maintain the temperature as constant, then the material geometry will change, means the material will expand with heat. So therefore, the length of the material will change and the area of cross-section of the material will change. So therefore, in this parameters case, we can take one is the length of the material, another one is the area of cross-section of the material. So these are the two materials properties or parameters related to the geometry, and the second one is related to the nature of material, that is specific resistivity. So let me take the equation, that is R is equal to rho L by A, where L is the length of the material, A is the area of cross section of the material, and rho is the specific resistivity of the material. And this simply relates the nature of the material based on different materials. They possess different values of rhos. However, the length and area of cross sections will decide the value of the resistance. If the area of cross section is more, then the resistance will be less. If the length is more, then the resistance will be more. That is simply proportional and inversely proportional relations we can conclude, right? So if you consider the resistance, you have to see the two concepts. So one is the temperature, whether the temperature is constant or not. So if the temperature is constant, automatically always the Ohm's law is valid. If the temperature is not constant, it means the resistance is also a variable because it depends on the temperature. So therefore we are not getting y is equal to mx form, because v is equal to ir seems like a y is equal to mx. That is an algebraic equation, shows straight line, right? So if r is not constant, then it seems like y is equal to x square, seems like a parabola. So that's how we can discriminate the two things in mathematical way, right? I think you're clear now why we have to maintain the temperature as constant and what are the parameters which influence the resistance. And next, if you take the resistance, so we can represent the resistance with a symbol like this. So this is what the resistance are. Now, according to the Ohm's law, we are applying the voltage across the material, which is V, and the current through the resistance is I, and according to the Ohm's law, V is equal to IR. Now, we may have composites of materials. So two materials are cascaded together, combined together, so that their lengths are different. Let me take, this is the material 1 and this is the material 2, where the length of the first material is different. Let us take it is L1, and the second material length is L2, And the area of cross sections, if you look at this area of cross section is some A1, which is different from the area of cross section of the second material A2. So therefore, the lengths are different and the area of cross sections are different, and this material is different and this material is some other material. Then definitely the rho also differ for each material. So therefore, if these parameters are different, automatically your resistance value will change. So the resistance value of my first material is R1, which is equal to rho 1 into L1 by A1. And the resistance of the second material is R2, which is rho 2 L2 by A2. Now these two are connected together. So the total resistance may be a series connection. So if you want to represent this in a diagrammatic way, so the first resistance, let me take a symbol R1, and the second material which is cascaded of R2. So this type of connection is called the series connection of resistors. Similarly, we have another type of connection called the parallel. So where the two resistances are connected in parallel. So the two resistances R1 and R2 are connected in parallel. But we cannot identify because here the magnitude will differ. So if you have only one resistance, the magnitude of the current is different. If you have two resistances, then the magnitude will different. So even the voltage is constant because the resistance will influence the magnitude of the current. So that's what we discussed in the first slide, right? So how you can identify this current? Now see, the same amount of current will flow in case of series connection. So the I is same, but what happens for the V? So we are applying the same voltage for the two resistances together, right? So therefore, the voltage will divide the potential difference will divide. So therefore, the V is equal to V1 plus V2. So that is like two tubes connected together in series. So therefore, the amount of water flowing in the tubes is same, right? So it means I is same. Now apply the Ohm's law here. V1 is nothing but I into R1, because it is simply Ohm's law, because the voltage across the two terminals of this resistance R1 is V1. So V1 is equal to the current is I again. So current is I means, so I into R1 according to Ohm's law. In the second case, which is I into R2. So together, the total voltage is V, which is equal to the voltage drop across the resistance 1 and the voltage drop across the resistance 2. So V is equal to V1 plus V2. So therefore, it is IR1 plus IR2. So this is the total voltage represented with a product of current and the total resistance known as R equivalent. Now I is common, so you can take I as common and you can cancel on both sides of the equation, so that the R equivalent we will get as R1 plus R2. So this is what the series connection of the two resistors. You can apply the same principle for the parallel connection where the current will divide, but the voltage is same because the two terminals of the resistor 1 and the resistor 2 are same. So therefore, V is equal to V1 is equal to V2, but I, because the two tubes are connected in parallel, means some amount of water will flow in one tube and the remaining amount of water will flow in the second tube. Therefore, the current will divide. Now, if you apply the same principle, so 1 by R equivalent will be equal to 1 by R1 plus 1 by R2. So this is how we are getting the equivalent resistances for the series and the parallel connections. In such manner, you can take any type of connections. Maybe you can take star connection or delta connection or combination of series and parallel connections. Using a simple series and parallel combinations reduction, you are going to find out the final value of the current. Of course, you can take any geometrical construction of the resistors, but you can apply the simple Ohm's law and you can reduce the equivalent resistance of any network consisting of n number of resistors. So like that, you can identify the equivalent resistance, right? So this is what a simple definition of a resistor and the resistance, and what parameters influence the resistance, and how you can find out the equivalent value of resistance. Of course, we can take the current division rule, voltage division rule, and so many concepts. Oh, okay, once if you understand the basic elements R, L, C, one by one, we can increase the things and we can analyze the networks with the different elements, and we can go for different type of concepts, right? So this is the basic concepts regarding the resistor.